Edgar in, and Geo and Elijah. We're gonna let Sam be in. Welcome, 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 welcome. I have for you in the Google Classroom the slideshow for today. Please open it up and we're going to start to take a look at it right now. I'm going to run around to the smartboard and we're going to get started. So let me just turn my screen so that you guys can sort of see me a little bit. And so really I can see the chat, and let's get started. So what we're doing today, actually, I'm going to change this so that I can sort of see myself. No, I don't think I'll be able to see myself anyways. So we're looking at graphs of proportional relationships today, okay? So first thing I want to talk about is I went through yesterday and I looked at who completed my Edpuzzle videos. I would say in this class, a solid 33% of you guys watched those videos. Not impressed with that number. Everybody should be watching those videos to go through and complete the second activity for today. Listen, I understand most classes, for example, social studies and science are not really having you do much work in the afternoon. I do not have that luxury. I have to give you an activity so that we can stay on pace. So those activities that you have for the second half of the day, I would suggest you need to watch the video. Your grade is based on whether or not you watch the video to complete the activity. Because it's new learning, it's not based off of, it is based off of what we did in class, but it's not exactly the same as what we did in class. It is brand new learning. So you need to make sure that you're watching those videos, following along with the videos, and completing them in your time. Does that make sense, you guys? Like I said, only about a third of you guys went through and watched it. So you need to, if you didn't watch yesterday's, you need to go back and watch yesterday's as well as today's. Okay? So today's goal, we have two goals for today. I can graph, and those grades already went in the grade book as a 50% if you didn't do it. So I can change those grades out if you complete it today, but it needs to get done. Okay? I can graph proportional relationships from an equation, and I can tell when two graphs are the same proportional relationship, even if the scales are different. So when we're talking about the scales, we're looking at our axes here, and the scales are the numbers that it goes by on the side, right? Okay? So the scales are the numbers on the sides of the graph, okay? So you're going to be looking at a bunch of different graphs. You're going to be calculating the slopes of those graphs, and then you're going to be deciding, do they have the same slope or constant rate of change, okay? So let's think about scale for today. We're looking on slide number 4 now, an unknown situation, okay? So the unknown situation starts on slide number 5. So follow along. If you want to open up the slideshow and then just sort of listen through the Zoom, that is perfectly fine. You can flip back and forth if you need to, okay? So we're looking at slide number 5, and it says an unknown situation. Here is a graph that could represent a variety of different situations. We need to write an equation for this graph. So remember, when we're looking at a proportional relationship, that this constant rate of change here, or the constant of proportionality, which we talked about last year, can be written as the constant of proportionality or another word for that is our slope. And in our video yesterday, I also called it the CROC, the constant rate of change. 3 different words. The video from yesterday is on slide number 7, I believe, Gio. It's the videos are linked into the slideshow. I'll show you at the end of the period, okay? So if we're looking at this guy right here, we can find our constant rate of change 2 ways, right? We can, if we think back to how we did it last year, because this is a proportional relationship, that constant rate of change is going to be our y over our x, right? So if we look at one of these points here, what is our y value on that point? The y-axis, the y value.
14.
14, very good, nice job. So our y, so the numerator in our constant of proportionality is going to be 14 over, what's our x value in that equation?
8.
Very good. So our constant of proportionality, or our slope, our rate of change, is going to be 14 over 8. So the equation for this, if you're going to write it on that line, you're going to write it like this: 14, and then the division sign, and the number 8. So that we had to find the constant of proportionality. We could have also drawn in a slope triangle. Find our rise and our run. Our rise is 14, our run is 8. So our slope for this would be the same thing. Rise over run is 14 over 8. So we have two ways that we can calculate our constant of proportionality. When it goes through our origin, you can simply grab one of your points on the line and write it as y over x, or you can draw in your slope triangle and calculate your rise and your run. Does everyone see the two ways that we just did that? Okay, wonderful. Let's take a look at the next piece of this here. Okay, so the next piece of this, we have a graph here, right? So we have our equation, and we said that our equation was y is equal to 14/8x, right? That was what we said our equation was. That's what this first graph shows us here. We need to graph the same situation here. So if we go, oh goodness, Mr. Main, you got this. 45, and then 14 times 5 would be, actually, you know what we're going to do? We are going to skip forward from here because I like this situation. I like the activity we're going to be doing in the lesson itself better. So I want you to, in your slideshow, listen. We're going to skip down to slide number 9. I know we're skipping around a little bit, but I like this activity a little bit better. So we're looking at different scales now. Okay, in your textbook, if you're looking at that textbook, you picked one up, it's actually going to be activity 2.3. The thing about the textbooks though, guys, is that some of the activities aren't actually in there. For some reason, some of the pages got left out. So I want everybody for this lesson today, I want you on the slideshows. Does that make sense? Perfect. So I want you guys on the slideshow for today. Okay? So when we're on the slideshow now, I want you to go down to slide number 10, because that's where this activity is going to start. Okay? So we have two different tanks of water. So let's look at this activity, two different scales. Okay? So two large water tanks are filling with water. Okay? Tank A is not filling at a constant rate, and the relationship between its volume of water and time is graphed on each of these sets of axes. So if you're looking at these two graphs down below, on both of these graphs, these are tank A. Okay, so we have our tank A here. So these two graphs, looking at these two graphs, before I read the next piece of this, what do you notice is different about these two sets of graphs? What do we notice is different about these two sets of graphs? So graph 1 and graph 2, what's different about them?
Graph 1 is closer to the corner than graph 2.
Graph 1 is closer to the corner. Okay. Landon, what do you notice is different? What do you think? Landon?
The numbers on the graph are different.
The numbers on the graph are different, right? So if you're looking at number one, graph number one, those numbers are a lot smaller, right? We have one doesn't even happen until here. But if you look at graph two, we're starting at the number 20 there. So that's one thing I want to notice. Geo also said that 2 is lower, right? So if you're looking like geographically at the line, it doesn't hit as high as this guy here. Good noticing there, Geo. Perfect. Jocelyn also noticed that the left has more numbers. Good. So we have a smaller scale here, and it has more boxes as well. Good notice there, Jocelyn. Melissa also said the numbers on the axes. Very good, Melissa. That was a really good point. And Landon made that same point, is that these scales are different. So this second one here, graph number 2, is a zoomed out version of graph number 1. Okay, so graph number 1 is really, really zoomed in, close, close, close. That number 2 is zoomed out. Okay, I wanted to make sure that you guys understood that and noticed that before we got started. Okay, so if we look at tank B now, tank B, I'm right here. Tank B is filled at a constant rate of 0.5 liter per minute. The relationship between its volume of water and time can be described by the equation V equals 1/2 T, where T is the time in minutes and V is the total volume in liters of water in the tank. So I'm going to rewrite that up top here because I want to keep that so that we know what each of these variables means. So when we're looking at this equation, we're saying our equation is V is equal to 1/2 T. And T, we said, represented the amount of time. And if we're looking at this, it's in minutes. Okay. And then the V represents the volume of water in the tank. So looking at this equation here, looking at the equation line here, what is happening to the tank? Is it filling up or is it emptying? Think about it. Tell me.
Emptying.
What are you thinking, Destiny?
Emptying.
If it was emptying, it would be going down.
It's filling up.
It's filling up because we started with 0 liters in that tank, right? Do you notice that, Destiny? We started with
Oh, I was thinking about the second one. I was looking at that one.
Oh, you were looking at the second one? Good. So the second one is also going to be filling because this is a positive 1/2. So it's a filling because it's a positive 1/2. Our rate of change is a positive number. Awesome job, Destiny. Awesome, awesome, awesome job. I'm so proud of you. Okay. Fantastic. So now we're going to use this information and these equations, and we're going to be graphing. Oh my goodness, this is crazy. Let me show you how we're going to be graphing today. So if we look at slide number 11, it says sketch and label a graph of the relationship between the volume of water V and the time T for tank B on each of the axes. Okay, so we're going to be graphing. So let's take a look at slide number 12 because we're going to do one of the graphs on slide number 12. So we're using this equation right here to help us to graph this equation. So we're going to use this table to identify some of our points on this that would fall on this equation line. So the way that we do that is we say, what happens when I take this equation right here, when I say V is equal to 1/2 T, right? How many liters are going to be in this tank here when the time is equal to 0 minutes? If you take this and you plug 0 in for T, when you say V is equal to 1/2 times 0, what is the volume going to be in liters? What's 1/2? Nice job, Edgar. It's going to be 0. Very good. It's going to be 0. Very good. When the time is 0, the volume is going to be 0. So what I want you to do on your screen, using your finger and your trackpad, or if you have a mouse, you can use your mouse. You're going to grab one of these dots from over here, and you're going to put a point on the 0, 0. Okay? Does everyone see how on my graph I put a dot at the 0, 0?
Yes.
Awesome. Perfect. Thank you, Landon. Nice job, guys. Okay, so I got my point at the 0, 0. Okay, next I need to figure out what is so when I see my volume is going to be 0.3, I need to figure out when is my volume going to be 0.3. So that means I'm going to take this 0.3, and instead of plugging it in for our T here, we're going to plug it in for our V. So we're going to say to ourselves, 0.3 is equal to 1/2 of T. So 0.3 is half of what number? Is a good way of thinking about it.
0.6.
0.6, nice job. So when the volume is at 0.3, our time is going to be at 0.6. Does everyone see how we did that? Nice job, Sam B. Okay, so if I want to plot that point on my graph, I need to go over how many? I need to go over to what number? Jocelyn, help me out. If I want to plot this point here, 0.6 comma 0.3, I have to go over to what number, Jocelyn? I'm going to start at 0. I'm going to go over to 0.6. Very good. And then up to where? Very good, Jocelyn, up to 0.3. And the 0.3 falls between the 0.2 and the 0.4. So I put a point right there that represents this point right here. Do we see how we did that? Nice job, Sam B.
Yes.
Awesome job. So now when the time is 1.2, now we need to figure out what's half of 1.2, guys. Nice job, Sam B. It's going to be 0.6. Okay? So when the time is 1.2 minutes, the volume is going to be 0.6 liters. So that means I need to go over to 1.2, over to 1.2, up to 0.6, and put my point. So I have 3 points on my graph now. Can I connect these and make a line, make an equation line here? I have 2 points. So can I connect them now?
Yeah.
Yes, I can. And the way that we're going to do that is you're going to come up to the toolbar up here, okay? And you're going to hit the line segment button, okay? So you clicked on it, and you're going to come here, and you're going to put it right over that point at the 0, 0, okay? And then you're going to pull it out until it goes through these 2 points that we plotted. And if you look at it, you can see it. It's right there. Okay, so everybody on their slides should have these 3 points and this line connecting them. What did you say, Landon?
Can you show us how to do that one more time?
Oh, so everybody's going to do this on their slideshow as well. Okay. I'm going to leave it up for another 20 seconds. I need you to make sure that you get this on yours as well. If you need me to show you how to do something again, please let me know and I can help you and I can do it again.
Line.
What's up, Landon?
Can you show us how to do the line again?
The line again? Yes. Let me just get rid of this one that I have here. So when you have your points on here, Landon, the way that you draw the line on is you come up to the toolbar at the top that has the line. It has like a line with two little points on the end of it. You're going to click on that. You're going to click on one of your your point at 0, 0. And you're going to draw this line so that it goes through each one of the points.
Thank you.
Not going to be perfect, but it's going to be as best as we can do here. Okay? And I'm going to make mine just pink so that everybody can see it. Okay? So everybody on their slides should be finding this plot. Awesome job, Sam B. So if we look at it, they intersect down here, but we need to also find where they intersect later on down the graph, because they are going to intersect later on down the graph. So let's take a look at, and we're going to zoom out our graph a little bit, and we're going to plot some more points on the next slide. Okay? So I'm going to move forward. Is that okay? Okay? If you need me to go back, let me know and I can. Okay? So we're looking at graph number 2 now, slide number 13. Okay? So now we took that graph that we just made here, and now we're going to zoom it out a little bit. We're going to see more of it. Okay? So if we're looking at this second one here on slide number 13, we're going to say at time 0, what's the volume going to be again? We know this. What's it going to be? Very good, Tiffany. It's going to have a volume of 0. So we can already fill that guy in. We already know what it's going to be. Okay? So then when we have a volume of 10 now, 10 is equal to 1/2 of what number? 10 is half of what number? What's the time going to be for this one? Nice job. It's not going to be 5, Tiffany. It's going to be 20. You had it right the first time, because 10 is equal to 1/2 of what number? So it's going to be bigger. It's going to be 20. So at 20 seconds, our volume is going to be 10 liters. So we're going to plot that point on our graph. Let's do it. So you're going to grab one of these points again. And you're going to, we put one at our 0, 0. No, Mr. Man, you got this. Mr. Man, you got this. Okay. And we're going to put one at 20, 10. So that means I need to go over to 20, up to 10, and put a point. Okay? So now, oh, this one's a little bit easier. We're going to say when the time is 20, what's our volume going to be? Half of that 40. I mean, when that time is 40, what's our volume going to be? Nice catch there, Tiffany.
20.
Nice job. Very good, Landon. It's going to be equal to 20 liters. So that means on our graph, we can take this point, we can take a point here and go over to 40, up to 20, and put it down. Ooh, look at that. They're almost going to meet. So now I think we're going to be able to find a meeting point here. So now we have 3 points. I can grab this line segment again. Click that line tool up at the top. Click on that point at 0, 0. And draw your line that goes through each one of the points that we drew here. I'm going to make this a pink one just so that we can see a little bit better. And now we're going to answer some questions about these 2 graphs. Okay, so make sure on your slideshow you have this graph drawn in for yourself. You moved your points onto the graph, you hit the line segment tool, and you connected them to create a line. Okay? Nice job, Sam B. I love it. You're keeping me updated. You're the best. Okay, so now we're going to use these graphs, and we are going to actually answer a few questions about them, okay? So we just graphed the same equation twice. You guys are so fantastic. Let's take a look at the last piece of this. Slide number 14. We're going to answer some questions. Okay? So if we're looking at, it asks us on letter A, after 30 seconds, which tank has more water? So which one of these graphs can we more easily see 30 seconds on? So the one on slide number 12 or the one on slide number 13? Which one, 12 or 13, can we see 30 seconds really easily? Well, let's look. We're not talking about 30 minutes. We're talking about 30 seconds. So let's take a look at which one has 30 seconds. So if I'm looking at this one, this right here in the middle has 1 minute. So I can really easily go over, and half of a minute would fall right here. So which tank, tank A or tank B, has more water at 30 seconds?
Tank A.
Tank A does. Nice job, Landon. Nice job, Sam B. So we're saying, so we can come back here and we can say, after 30 seconds, which tank has more water? Tank A. And which one of those graphs helped us? Graph number 1. So which graph told us that? Or you could say the graph on slide number 12. Okay? You can say it one of two ways. Okay? So then, at approximately which time do both of the tanks have the same amount of water? And we're not talking about that initial. We know that at 0, 0, they have the same amount of water. But we're looking for that second spot where they have the same amount of water. Which graph has a second meeting point on it? Graph number 1 on slide number 12 or graph number 2 on slide number 13?
Graph 2.
Graph 2, nice job, Edgar. Graph number 2 has a second meeting spot. If you see that right here, it has a second meeting spot. And how long does it take for them to hit that second meeting spot, for them to have the same amount of water?
60 minutes.
Edgar said 60 minutes. Tiffany also said 60 minutes, and so did Sam B. Jocelyn, what are you thinking? How long is it going to take for them to have the same amount of water again? Nice job, Elijah. It's going to take us 60 minutes. Very good. So if you click back to slide number 14, we're going to type in this box. Approximately when will they have the same amount of water after 60 minutes? And which graph did we have to use to help us find that? Graph 1 or graph 2? Nice job, Tiffany. It's gonna be graph number 2, right? Because we had to look at that zoomed out graph to see where are they gonna meet again, and it hits right at that graph number 2 at that 60 minutes. Good. Okay. Last question we're going to look at. Approximately what time does each tank contain 1 liter of water and 20 liters of water? So let's look back at these guys. So when do they have 1 liter of water? So if we look here, how long does it take graph A to have about 1 liter of water? How long? That's about here-ish, right? And we can round it down. How long is it going to take tank A to have 1 liter of water? Oh, I went the wrong way. Mr. Me. Melissa is here. Thought she was here. Okay. So it's going to take about 1 minute for it to have, nice job, Sam, nice job, Tiffany. It's going to take about 1 minute. Very good. Awesome job. And we're not going to do the last one because I feel like you guys are doing pretty okay with this. And I want to make sure that I don't finish you guys too late. Okay? So I'm gonna leave these answers up here for you. After 30 seconds, we said tank A. So make sure that these are getting copied down on your slide. And while you're getting these copied down, let me talk about what you have to do this afternoon. Okay, so this afternoon is actually a little bit easier than what we did today. You're not graphing, you're calculating slopes of lines. So if you click onto slide number 15, I have for you the links to the videos. So Geo, just like yesterday, on one of the slides in the slideshow, it's gonna have links to videos like this. It's gonna say cohort 2 and cohort 3. You're gonna click on that cohort 2 and it's gonna open up an Edpuzzle video, okay? And it's gonna look like this. And you're gonna do the last activity for today. You're gonna watch this video and do it along with me. I'm gonna be giving you all the answers, so it's gonna make it pretty easy for you to follow along. I'm gonna have you pause from time to time to do some things, but I'm not gonna ever leave you without any answers, okay? So if you look here, all you're doing with these are, you're finding the slopes of these graphs, and I put some timers on here so that you don't spend too much time doing that. If you look at 17, 18, and 19, you have to calculate the slope for each one of these lines. In the video, I show you how to do it. We do one of them together. And then you're gonna work on the other 8. You're only gonna take 10 minutes to do that though. So if you didn't get a chance to finish all of the slopes in those 10 minutes using this timer right here, you're gonna stop. And then you're gonna play the video again and you're gonna keep going. Yes, so what you're doing for homework this evening or for afternoon work this evening, it's not homework. It's gonna be 16, 17, 18, 19, and then the exit slip on 25, okay? The slides 20 through 24, you're sorting the graphs afterward. Everything you're doing along with me, everything you will get answers for in the video. So don't feel like, oh my God, she's expecting me to do all of this. I have no idea what I'm doing. If you watch the video, everything you need to know is there. Does that make sense, you guys?
Yeah.
So I want to get more people to watch the video than did yesterday. If you didn't watch yesterday's video, I put it in Power School as a 50. If you complete it today, I can swap it out and change that grade out for you. But you need to watch the video through Edpuzzle. Okay? Is everyone clear on what they need to do for today?
Yeah.
Yes.
I can, Melissa, yes. So for slide number 13, that's what our graph looked like. So we had 0, we had 20, and we had 20. And then this one will be 60, and this one will be 40. Okay. You don't have to go back and do those, Tiffany. So those ones at the beginning, you don't need to go back and do those. I skipped over them because I wanted to get into this activity for today. You don't need to do the slides at the beginning. You just need to focus on 15 all the way to the end. Okay, and I know it looks like a lot of slides, but it's not that much work because you're just going to be on 5 of them. You're just going to be sorting them and copying and pasting them onto the appropriate slides. So I just want you to not focus on how much it's going to ask you to do because it's not too bad today. Okay. So you guys did fantastic. If you have questions about any of the work for that we did today or you're doing this afternoon, send me an email. We can set up a Zoom session this afternoon to go through it, okay? Send me emails if you need assistance with anything, and I will see you all tomorrow. Awesome job today, guys.
Bye.
Bye, guys.
Bye. Have a good day.
Bye. Have a good one.